Two things to focus on today. Rotating 180 degrees, which we've already talked about, so this will be kind of like review, but I want to show you a trick with coordinates. And then rotating about a point that is not the origin, rotating about non-origin. This is kind of tricky, so I'm going to spend most of my time on this second one. So let's knock this first one out of the way. Rotating about 180 degrees around the origin with coordinates. So I'll give you three coordinates. I'll give you 1, 3. I'll give you the points -2, 4. And I'll give you the point 4, 1. Or sorry, -4, 1. All right, so we'll just say those are here, here, here. That's not a very good picture, but whatever, that doesn't matter. Okay, so those are your 3 points on a triangle. If we're going to rotate that 180 degrees. When you rotate something 180 degrees, there's two tricks. The first trick is it goes to the diagonal quadrant. Diagonal quadrant. The quadrant just means that you've split your coordinate plane, your graph, up into 4 corners. Quadrant 1 is the upper right, quadrant 2 is the upper left, quadrant 3, quadrant 4. So wherever your point starts in, it's going to end up in the one that's diagonal from it. So for example, the point 1, 3 is in quadrant 1, so it's going to end up down here somewhere in quadrant 3 because that's the one that's diagonal. These 2 points are both in quadrant 2. Diagonal from 2 is 4. So both these points are going to end up over here somewhere. So your triangle is going to be something like that. But you need to know exactly what point is it going to end up at. So let me show you with a pencil. 180 degrees. If this is your clock and you're pointing at like 1 o'clock, 180 degrees from 1 o'clock is 7 o'clock. So you're going to end up down here somewhere, which is going to be over 1 and down 3. How did I know that so fast? Because it's the exact same numbers that we have. It's just the opposite signs, people. That's how easy it is. So if this is A prime will be -1, -3. The same numbers that it started with, but the opposite signs, and that is going to work no matter what quadrant you're in. So for example, let's say this is point B, -2, 4. You're pointing at about 11 o'clock if this is a clock, so 6 hours after 11 o'clock is 5 o'clock. So you're pointing at 11 o'clock here, and you're pointing at 5 o'clock down here. So B is going to end up down here somewhere. It is going to end up at 2, -4. The exact same numbers, but opposite signs. Instead of a -2, a +2. Instead of a +4, a -4. You see how easy this is? Rotating 180 degrees is probably the easiest thing to do. So what's the opposite of -4? +4. What's the opposite of +1? -1. So C prime would end up over here, and your triangle would look something like that. So that's rotating 180 degrees. You just keep the same numbers, change the signs, bada boom, you're done. Yay, easy. Now, to go from super easy to super hard, this next one is not easy, sorry. So, rotating around a point that is not the origin. Before I explain that, going to rotate around the origin, the easy way, the old way, which may not even have been easy to begin with. So let's get that down first before we go to a point that's not the origin. So let's say we got to rotate this point right here, that is the point 1, 5. About the origin, and we're going to go 90 degrees clockwise. All right, if you use the clock analogy, this is your center, that's the beginning of the hand, the center of the clock, is pointing at 1, 5, which if this is a clock, that's about 1 o'clock, I'd say is where that hand is pointing. So 90 degrees, unlike 180 degrees was 6 hours, 90 degrees is only 3 hours. So what's 3 hours past 1 o'clock? 4 o'clock, so you'd be a little bit below. This would be your 3 o'clock, 6 o'clock, 9 o'clock, 12 o'clock. So if you're pointing at 1 o'clock, you'd end up down here somewhere around 4 o'clock. So we'll call this A. A prime is going to be somewhere over in here. Okay, but we need to know exactly where over in there. So to do that, you need to imagine the hand in your clock is not straight. It's got a 90-degree turn in it. Let me explain. We're going to draw the hands in our clock going either straight up, straight across, straight down, or straight to the side, and then straight over to the point. So on this point right here, the easiest way to get there is to go straight up and then straight over. So now we've got a crazy looking clock. The hand in the clock, instead of being straight, now has a bend in it. And what are the dimensions of that hand? Well, to get from the origin to that point, you had to go up 5 and over 1. And now this hand that goes up 5 is going to rotate 90 degrees. 90 degrees would be right here. So this is now your 5 distance, this hand. And remember, it's got a 90-degree bend in it. It went down 1. So that would be like rotating. I've heard another teacher call this the Hangman Method because this bend in the hand of the clock is supposed to look like a hangman thing. Whatever. You can call it that if you want. I prefer the clock analogy. So the hand in your clock went up 5 to get to this point and over 1. That's how you get to the point 1, 5. So you just rotate that crazy looking hand on the clock 90 degrees and it goes to right here, over 5 down 1, which is the point 5, negative 1. So so A prime, we found it, is 5, negative 1. So it's not that difficult to do if you're rotating around the origin, as long as you're using the crooked hand in the clock method. All right, and you don't have to go up and over. As long as the first distance you go is straight across or straight up and down. So say we wanted to go to this point by going, say our hand on our clock is short and then it's broken this way, and the broken part is the long part. So we went over 1 and up 5. If we're going to rotate that 90 degrees, it's the one that comes off the center first that you got to imagine rotating 90 degrees. So the one that comes off the center first is pointing at the 3. So 90 degrees clockwise, it would be pointing at the 6. It doesn't change length, so it's still a 1. And then you would go over 5. Can you see how, I don't have any, if this is your hand and you rotate it, it would look like that. You guys see that? So you still end up at down 1, which is negative 1, and over 5, 5, negative 1. So we still ended up at the same point. This one might be a little bit harder to visualize. The only reason I showed you that is because it doesn't matter how you get to this point as long as the first direction you go is either straight across or straight up and down. All right, we're going to use that same method if the center of the clock is not the origin. So let's say that we're going to we'll rotate that same point, 1, 5. I'll just leave it there. We're going to move that point 90 degrees clockwise. But instead of the center of our clock being at the origin, now the center of our clock is going to be at negative 2, 1. Say this point right here. That's the center of our clock. You still do the same technique I just showed you, the broken clock hand thing. You want it to get from the center of our clock to here, instead of just drawing a straight line like a normal hand on a clock is, we got to go either straight up and down or straight across. So I'm going to choose to go straight up and down first. So how far up do I have to go to get from this point up to that point? 4 spaces, because I'm already up 1. I'm at 1. And this is all the way up at 5, so I got to go up another 4 spaces. And how far over did I have to go? Well, I was all the way over here at negative 2, and I got to get over to positive 1. So from negative 2 to positive 1 is 3 spaces. So to get from the center to the point I'm trying to rotate, I had to go straight up 4 and then break the hand on my clock and go over 3. Now I'm going to rotate this 90 degrees clockwise. So what is the first direction coming off the center of my clock? Straight up 4, pointing towards 12 o'clock, straight up. So what's a 90-degree rotation from straight up? Straight to the right. So my first direction is going to be to the right, 4, and then down 3. And I got this kind of all out of whack here, but it's not really to scale, but that doesn't matter. So that's always going to be a 90-degree angle. Remember, the hands coming off your clock, if they're not broken, they should make a 90-degree angle after you rotate, because you're rotating 90 degrees. If you start pointing at the 3, you're going to end up, or if you start pointing at 12 o'clock, you're going to end up pointing at 3 o'clock. And the distances don't change. We're still going to use 4 and 3. So you went up 4 and over 3, so now you rotate that, and now you're going to the right 4 and down 3. So what is to the right 4 spaces of -2? +2. And what is down 3 spaces from 1? -2. So we end up at 2, -2. That would be our A prime in this one. 2, -2. Over 4 spaces from the center, which is at -2. So over 4 spaces from -2 gets us to +2. And down 3 spaces from 1 gets us to -2. 1 minus 3 is -2. So that's our new center. So this is tricky, I understand, and I'm only giving you one example here. And you're really only going to have one problem in the do section that's like this. So you're not going to get a lot of practice on this, but you will get to try it today on your own, and then I'll go over it again tomorrow in the beginning of class after you've tried it, and then hopefully it'll make more sense the second time you see it.